So now let's talk about the definition of a rational function, like what makes something a rational function instead of a polynomial. And what they look like, the form they take, r of x, a rational function, is one polynomial, p of x, divided by another polynomial, q of x. And both the p and the q are just polynomials. And the domain for any rational function is all real numbers except what makes the denominator 0? So remember that polynomials, for one thing, their domain is all real numbers, always. And that's because you can put in any value for x into a polynomial. It's all allowed. The domain, though, is the x values. And so what we have to learn here for rational functions, since it's one function divided by another, you're not allowed to divide by 0. So we don't want this denominator to equal 0. Then the function will not exist, okay? So let's take some examples of finding the domain of a rational function. Number 1, f of x is equal to 1 over x minus 2, okay? So to find the domain, really it's all real numbers, except we can't have 0 in the denominator. So we would say, well, x minus 2 cannot equal 0, right? So x cannot equal, add 2 to both sides, 2, okay? Now in your online homework, it usually has you write it such as this. The domain is all x's such that x cannot equal 2. Okay, they'll give you, some of that formatting, but they're writing it in inequality notation rather than in interval notation. I don't know why I like the interval notation better, so the interval notation would just be everything except the number 2. So that's negative infinity to 2 parentheses, union with 2 to infinity. Those are both correct answers. It's just different formats of the formats of them. All right, let's do another example. We have f of x is equal to x plus 1 divided by x plus 1 times x minus 3. Okay, so notice that this is already in factored form, so it's going to be pretty easy to find what makes the denominator 0, right? Set the denominator equal to 0. I did want you to notice on this one that x plus 1 and x plus 1, would cancel out. That's true. And however, it still is in the denominator, so it still does make the function not exist. It's not in the domain. In other words, this would be 0 divided by 0, which is also a no-no. So we still want to set both parts of the denominator to be not allowed to be 0. So x plus 1 can't equal 0, so x cannot equal negative 1. And x minus 3 cannot equal 0, so x cannot equal 3. So our domain, we're going to have x such that x cannot equal negative 1, comma 3, and bracket. They use those fancy brackets. And then in interval notation, we would just need to take out the negative 1 and the 3. So we would start at negative infinity, go to negative 1, parenthesis, union with negative 1 to 3, parenthesis, union with 3 to infinity. That means it's all the numbers except -1 and 3. Let's do one more example. All right, so the last one, f of x is equal to x squared minus 4 divided by x squared minus 9. Okay. So in this one, you have to do a little bit of work. So yeah, it's true that the numerator does factor x plus 2 times x minus 2, right? That's that difference of two squares factoring. Hopefully that looks really familiar to you. The denominator also is a difference of two squares, so that one would factor to x plus 3 times x minus 3. Okay, for the domain, we only care about the denominator. We can't divide by 0. 0 in the numerator is actually okay. That's just the number 0. But 0 in the denominator is that no-no. So we have x plus 3 can't equal 0. So x cannot equal -3. And x minus 3 cannot equal 0. So x cannot equal 3. So our domain is all x values such that x cannot equal -3 or 3. In interval notation, we would have -infinity to -3 parenthesis, -3 to 3, and parenthesis 3 to infinity to include all the numbers except those two numbers.